Today we're going to talk about finding absolute or global extrema. In the previous sections we found relative or local high points and low points, like the ones I have labeled in green. The absolute or global extremes are the absolute highest and lowest point on the curve. On this graph, the absolute max is the left endpoint. That point has the largest or the highest y value. And the absolute min is the same as one of those relative extrema. That is the point with the absolute smallest y value. So the basic idea is an absolute or global extrema can occur at one of two places. You can have it at an endpoint, like we saw with that absolute max, or it can occur at a critical point, which we saw with that last example's relative min. And so I have a theorem that describes when we have absolute extrema and how to find them. So first of all, anytime you have a continuous function on a closed interval, it has to have a highest and a lowest point. If you want to find that highest and lowest point, first thing you're going to do is find all critical numbers. That would be places where the first derivative is 0 or the first derivative doesn't exist. And then you evaluate the function for all critical numbers in the interval as well as all the endpoints. And you just look at the y values. The largest y value is the max, smallest y value is the min. So let's do an example. If we want to find the absolute max and min of the function f of x equals x to the 8/3 minus 4x to the 2/3 on the interval 0 to 6, the first thing we have to do is find all the critical points. So I'm going to find the derivative of this function, and I get 8/3 x to the 5/3 minus 4 times 2/3 x to the negative 1/3. I can write that as 8x to the 5/3 over 3 minus 8 over 3x to the 1/3. To find critical points, I have to figure out when does this equal 0 and when is it undefined. To do that, I'm going to get a common denominator and write this as a single fraction. My LCD is 3x to the 1/3, so I just have to take that first fraction, multiply the top and bottom by x to the 1/3. That gives me 8x squared over 3x to the 1/3. To get the x squared, I added the exponents. 5/3 plus 1/3 is 2. All right, and then minus 8 over 3x to the 1/3. And so I combine that into a single fraction. And then the idea is my derivative equals 0 when the numerator equals 0. 8x squared equals 8 when x squared is 1, or when x is plus or minus 1. And the derivative doesn't exist when the denominator equals 0, and x to the 1/3 equals 0 when x is equal to 0. So I have found all my critical points, and I have 3 of them. And then the next step is I make a table of values. And my table of values is going to include the endpoints of the interval I'm looking at. So that's 0 and 6. And then I put any critical numbers that occur between those endpoints. So I'm going to include 1. I've already got 0 listed. I don't include -1. It's not in the interval I'm interested in. Then I take these x values and I plug them into the original function to get the corresponding y value. If I plug in 0, I get 0. If I plug in 1, I get -3. And if I take 6 and plug that in, I had to use a calculator and I rounded to the nearest tenth. I got 105.7. Then the idea is that the smallest y value is my minimum and the largest y value is my max. And that's the basic idea we're going to use in all of the problems in this section. So let's do the same thing for example 2. First thing I have to do is find the critical points, which means I have to find the derivative. I have a quotient in this problem, so I'm going to have to use the quotient rule. My numerator, my u, is ln x, so u prime is 1 over x. My denominator, my v, is x squared, so v prime is 2x. Using the quotient rule, I take u prime times v minus v prime times u, and that is all over v squared. This becomes x minus 2x ln x over x to the fourth. And then I'm going to factor an x out of the numerator. Because now I have a common factor of x, I can cancel that out. And so in simplified form, my first derivative is 1 minus 2 ln x all over x to the third. Okay, so where does this derivative equal 0? It equals 0 when the numerator equals 0. 1 minus 2 ln x equals 0 when 1 equals 2 ln x, or 1/2 equals ln x. So I isolated the log, and then to write this in exponential form, natural log is base e, so I get e to the 1/2 equals x. Or we could say x is square root of e. So that's one of my critical points. Where does this derivative not exist? It doesn't exist when the denominator equals 0 or when x equals 0. But if you look at the original function, x equals 0 isn't even in the domain of the function. And so it's technically not a critical point. Finally, I'm going to make a table of values. I include the endpoints of my interval. So that's the 1 and the 4. And then I'm going to use a calculator and check, is square root of e somewhere between 1 and 4? And yes, it is. I put it into my calculator. It's 2 or 1 point something. So now I have to take my endpoints and my critical point, and I plug that into the original function to get the corresponding y values. I used a calculator to help me. When x is 1, y is 0. If I plug in square root of e, I rounded to the nearest hundredth. I got about 0.18. And when I plugged in 4, I also rounded. I got 0.09. The point with the largest y value is the max. So it looks like we have a max at square root of e. And the point with the smallest y value is the min. So it looks like the 0.10 is the minimum here. Finally, let's use this same process on an application. Example 3 says, for a certain SUV, m of x equals the following. And they're giving us an interval. They're saying the x values only range from 30 to 60. This function is only valid for x values from 30 to 60. These are my endpoints of my closed interval. This function represents the miles per gallon. So m is miles per gallon at a speed of x miles per hour. So x is speed. We want to find the absolute maximum miles per gallon and the absolute, I should say minimum, and the speeds at which they occur. So same problem, it's just in the context of a word problem. So first thing I have to do is find my critical points, which means I have to find my derivative. Derivative of this function is going to be negative 0.03x plus 1.31. And then I set that thing equal to 0 and solve for x. So x is 1.31 divided by 0.03. I put that into my calculator, rounded to the nearest tenth, and I got 43.7. So now that I found my critical point, I'm going to make a table of values. I put the endpoints, 30 and 60, into my table. And my critical point is between those endpoints, so that also goes into the table. And then I take these values and I plug them into that original function. I used a calculator to help me. When x was 30, I got an m value of 18.5. When x was 43.7, I got 21.3. And finally at 60, I got 17.3. So the point with the largest y value is the max, and the point with the smallest would be the min. And so let's see, to answer the question though, X was speeds, and so it looks like our max fuel efficiency was 21.3 miles per gallon. And that occurs when you are driving at a speed of 43.7 miles per hour. Our minimum fuel efficiency was 17.3 miles per gallon, and that occurred at a speed of 60 miles per hour. All right, that's it for this lesson. And as always, if you have any questions that come up while you're doing homework or your worksheet, please send me an email or drop by office hours.